Hello, my name is John Newstead. I'm a soil scientist at Delta T Devices, and today we're at NIAB East Malling, and Mark Else, the head of crop science and production systems here, is going to take us through some of the work they're doing in their controlled environmental chambers. So why are they doing the work, what are their hope for their outcomes, and of course what equipment they're using.
Here we are in this growth chamber, where this is part of a DEFRA Farming Innovation Programme grant that we won recently. It's led by Vertical Future, but it also involves NIAB and Delta T Devices and other partners as well. What we're trying to do in this experiment then is to impose deficit irrigation on these cropping strawberry plants. And so the idea behind this then is to try to reduce the amount of water that we use to grow crops in this controlled environment facility, reduce the amount of fertilizer we're applying. But we know from previous work carried out more than 20 years ago that if we apply deficit irrigation carefully and at the correct stage of development, we can then reduce inputs, but we can also improve fruit quality, phytonutrient content, flavour, and help to assure shelf life. One of the things we need to do when we're applying deficit irrigation is to control the extent and the degree of stress quite carefully, to inform decisions on how often to irrigate, how long to let the coir dry down for, when to re-irrigate. We need lots of high quality real-time data. And so in each of these pots here, in these growing troughs in the growth room then, each of the troughs contains a Delta T Wet 150 sensor. And this sensor then is buried within the coir. You can see one here where you can just about see the sensor poking out. This sensor is measuring moisture content in the coir. It's measuring EC, pore EC within the coir, and it's also measuring the temperature of the substrate. And what we do then is look at this real-time data online and understand how long we need to dry the crop for and when we need to re-irrigate. And the idea is to impose a controlled drying stress on the plants. And by doing so, we can reduce canopy growth and canopy height, which can be important in these sorts of environments. But as I mentioned before, the aim is also to produce high yields of Class 1 fruit, but with extra phytonutrient content, better flavour and an assured shelf life potential. It's important that the data from each of these troughs is available in real time. For example, the coir volumetric moisture content, the temperature, the humidity. We need to be able to see that data in order to be able to inform our decision making. So all the data then is collected through into a GP2. The GP2 then uploads the data into the cloud, and we can see that in real time on our smartphones or our tablets or on the PC. And so that helps us to impose the correct treatments for the right length of time. It's also important for us to measure the environmental climate within here. So we have a Delta T sensor currently measuring temperature and relative humidity. And from that, then we use a script in the GP2 to calculate vapor pressure deficit. And it's important when we're applying these deficit treatments that we apply the treatments in conjunction with a known vapor pressure deficit to make sure that we're not applying a stress that's too severe. Okay, so now we've moved into one of our smaller growth chambers. What we're doing here then is trying to understand what the optimum cropping potential is for any given strawberry variety. So this particular variety is Malling Ace, which we know has very good fruit size, very good flavour. And typically in normal polytunnel production outside, we'd expect Class 1 yields between 1.1, 1.2 kilograms per plant. So we're very interested under this optimum growing environment where we can grow these plants all year round, what the actual optimum cropping potential is. We've done this work in the past with previous varieties, and we've shown that yields of up to 3.2 kilograms of Class 1 fruit per plant are achievable. These plants now have probably been cropping for 4 or 5 months. We're up to just over 2 kilograms of Class 1 fruit per plant. And we'll probably leave this experiment running for another 4 or 5 months just to see what the optimum yield is we can gain from these plants.
Thank you very much, Mark. I hope you found that interesting. If you would like to find out more, please do refer to the Delta T website, and hope to see you again soon.